Hey guys, welcome to Little Pug Games and welcome to today's episode. Today we're going to start off where we finished off in the last episode, and we're going to implement some enemy movement today. So we're going to implement some chickens. So if you ever played Zelda and you hit the chickens, a bunch of chickens start to swarm you, and that's kind of what we're going to build today. So we're going to build some characters, some enemy characters, and what they'll basically do is pursue the player. And without further ado, let's get started, you guys. First thing we want to do is, again, we want to grab our sprites for our character, and we'll use these sprites right here, the last four of the chicken sprite sheet. We'll drag them over and we'll place them in Unity. And again, if you watched the last episode, this will just create an animation and an animation controller. Chicken run. Let me check one quick thing. So it's actually just the last two. So here's a quick thing I'm going to do. So whenever you want to change an animation, you can go into the animation tab, open up the sprites, and then mess around with the keyframes. So right now we just want the last two. So we can select both of these and drag them to the start. So now we'll have a chicken running animation. Let's give it a quick go. Okay, that's a fast chicken. Okay, let's slow it down a little bit. Alright, so 0.6 is fine. And so let's think about what we're going to do really quickly. So enemy chicken. Just going to rename this game object. And so what we want to do is at any point in time the chicken is going to be away from the player, like so. And we want to change the chicken's velocity so that it's in the direction of the player. So if he's here, he'll move in this direction. And if he's in the line of sight, for example, of the player, he'll move in this direction. A way to do this is to grab the player's transform, and in that manner, we'll know where the player is at all times. And then we can also use a raycast to make sure that the player is in view. So if we use a raycast and, for example, we have an obstacle right here, it won't hit the player, it'll hit the obstacle. So in that case, we might not want to follow the player. But that's how we're going to implement this. We're going to implement it by creating a rigid body to control the velocity, and then we're going to see where the player is at all times during each update and move towards that direction. So let's add a rigid body to our chicken. And again, this is kinematic because we are controlling the physics of the object through a script. So just switch it to kinematic. We'll go into scripts and we'll say enemy pursue script, enemy pursue movement, or enemy pursuit script. Sure. Alright, so we're going to go to the enemy chicken and we're going to add this script here. Alright, so next we'll start coding it up, and I'll make this a little darker so we can see the chicken. Alright. Let's start. Alright, you guys, let me zoom in a little bit. During my explanation right now, I mentioned that we're going to need the player transform. So let's create a private variable, player transform. And here's a little trick. We're going to make this static so that every instance of this script will be able to access this player transform. And we'll set that up in the start method. So start. And the way we want to do this is if the player transform is equal to null, then we want to set it. And we'll do this by using a GameObject method. So GameObject.find with tag, and the tag we're using on the player is player. So we can find the tag named player. And so it'll find that game object, and then now we just have to get the transform of that game object, and we're done. So player transform will no longer be null, and every other script that goes through the start method it won't need to go through this code. So just the first time. Alright, so we'll do a private, update. And okay, wait up. For physics. So I want to go over that because I changed my player's movement in the last episode using the update, but today we're going to use a fix update method. So again, we want to know where the player is compared to where the chicken is. So we're going to get a vector to figure that out. So direction to player is equal to, so our target is the player, so we're going to say player transform dot position minus our current position, and this will give us a direction to the player. Another thing we might need for this character, for the enemy chicken, is a speed. So we're going to add a float speed, and we're going to use this speed to move the chicken. So direction to player, and again, let's do this in fix update. And we're going to, so how are we going to change the chicken's velocity? We're going to use a Rigidbody. So let's also add that quickly to the script here. So Rigidbody 2D, we're just going to name it Rigidbody. And we'll set that here is equal to get component and Rigidbody. Alright, so all we need to do now is Rigidbody.velocity is equal to direction to player, and we're going to use .normalized. Remember, so .normalize will normalize a vector, so it'll have a magnitude of 1. And after which we can just change it to the speed we want. So magnitude of 1 times speed will equal a velocity with a magnitude of whatever we set our speed to. Let's test this out with one chicken really quick. So here we have enemy chicken, and we're going to set its velocity to 2. And let's see if this works. Oh, wait. I know what I did wrong. Wait up. So I didn't tag the player with player, but let's tag it right now. So here's the tag, and okay, so there you go. Chicken's chasing me. Okay. So again, we see that the chicken is not facing the right direction. So let's change that really quickly. So let's go back to our scripts. So this code is basically going to be this code, but with a couple changes. So set orientation, and if more so, depending on the Rigidbody.velocity.x, So we just want to get the x value of our velocity. If that's greater than 1, then we're moving to the right. So let's get rid of this animator, and we're going to need this sprite renderer. So let's get that really quickly. Oh, there you go. All right. Whoa, 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 whoa. Okay. Let's do this. All right. So let's get the sprite renderer really quickly. Private sprite renderer. Sprite renderer. All right. So we set this up, and oh, sorry. Jazz music. It's good. All right, so let's check it out really quick, and we should see the chicken move. Oh no. Oh, okay. Sorry guys. So I forgot to actually get the sprite render. So let's do that really quickly. Component, and we want to get the sprite render. Let's go back really quickly, and let's test it out. So hopefully the chicken should be moving in the correct direction now. Yay, okay, cool. All right, so let's make this more Zelda-like. And all right, I'm gonna fast forward really quickly. All right, so finished. I have a bunch of chickens on the screen, and so I'm gonna try to run away. All right. We can also add some colliders so that the chickens stay away from each other. We built this right now, so we have these chickens pursuing the character. So here are some challenges for you guys. Might as well let you guys do something cool. So can you write some code so that if the character is X distance away, the chicken will stop? So float stop distance, stop distance. So here we have the direction to player, which is also the distance to the player. So using this, can you make the chicken stop given a stop distance? Remember, magnitude gives you the magnitude of a vector, so you could also use that. And here's another challenge for you guys, is can you add a box collider to these chickens so that they don't collide with each other? That's it for this episode. So today we went over how to create an enemy with a pursue type movement. So the chickens in this episode will pursue our player character given the player's position. And we use that using some vectors and some vector math. And we basically took the direction from the chicken to the player, and we started to move the chicken in that direction. So that's how we implemented that today. Yeah, so I hope you guys learned something cool, and I appreciate you guys watching. You guys have a great day, and bye.